All right, this is chemistry lesson 7.05, and we are on part 1 of 2 parts. So in this series, we're dealing with type 2 cations. And remember, we said way back when that a type 2 cation is a cation with more than one possible charge, with more than one possible charge. And if you look on your ion charts, if you don't have those with you, go ahead and, or don't have them out, go ahead and get them out. If you look at the bottom, you'll notice you have iron with a Roman numeral 2 and iron with a Roman numeral 3. That means that iron can form either a +2 charge or a +3 charge. A copper can be +1 or +2. Tin can be 2 or 4, so on and so forth. So how do you know which cation you have? Well, you have to kind of do a calculation. Right away, I see I've kind of got a little bit of an issue here. I've got some duplicates. Let's cross those guys off. So let's look at this first example here. So let's look at FePO4. So we said if this was a type 1 cation, we would call this iron. This would be iron, and PO4 is a polyatomic, and the name of that is phosphate. But we have 2 irons. We have iron 2, so it could be, and the way we write this out is we put the charge as a Roman numeral. So this is equal to the charge. This would be Fe plus 2 or Fe plus 3. So we have to figure out, is this iron 2 phosphate or is this iron 3 phosphate? These are the 2 possible names. And the way we're going to solve this is you have to remember that the net charge has to equal 0. So our net charge must be 0, must equal 0. Phosphate has a charge of -3. So this has got a -3 charge. If I have iron with a +2 charge, does that end up being 0? Nope. If I have a +3 charge, does that end up being 0? Yes. So that tells me when I look at my charges, this is the only one that has a net charge of 0. So that means this can't be the correct answer. So it has to be iron 3 phosphate. But what we have to do here is we have to look at the total anionic charge, which is the total negative charge, total anionic charge, negative, to determine which type 2 cation I have. All right, so we said that this is going to be iron 3 phosphate. All right, let's work on these 2 copper chlorides. Yeah, do the copper chlorides. So I have copper can be, change colors here. Copper, I can have copper 1, or I can have copper 2. And these are both chloride compounds. So one of these is copper 1 chloride and one of these is copper 2 chloride. Chloride has a minus charge, or has a negative charge, has a charge of -1. So if I have copper 1 chloride, when I look at that formula, I could have 1 copper to 1 chloride, which is what I have here. So if this is -1, and I only have one of these, that means this charge must be +1. So that must be copper 1 chloride. Over here, I've got two chlorides now, so I've got a -1 and a -1. So my total negative charge is -2. That means that my total positive charge must be +2. Well, in order to have a +2, and notice I only have one of them, I have to have a compound that has a +2 charge. That means that this is going to be copper 2 chloride. Do you see why it would be wrong to write copper 1 chloride here? If I did that, I would have a +1 and a -2, and I wouldn't be equal to 0. So you still have to hold to this net charge equaling 0. All right, let's do a sample problem. Let's do this SnNO3 parenthesis 4 here as a sample problem. And I'll pause, or go ahead and pause the video, and we'll do the answer when we come back. All right, welcome back. I'm grabbing an ion chart because I don't really remember off the top of my head the type of, I think tin can form 2 and 4. So I think my choices here, I have an SN2 and an SN4. That's from memory. So I have to find out what my total negative charge is. Nitrate has a -1 charge, and I have 4 of them. So this has to be -4. That means I only have one of these tin. That means this tin has to be +4. So this has to be tin, 4, nitrate. Okay, let's try another one. Last step we're going to do here are these iron oxides. And iron can form, so we have our choices here. Our iron can be 2, or iron can be 3. All right, so go ahead and pause the video and see how you do with this. All right, welcome back. I don't really like this pink color. I don't think it's dark enough, so I'm going to switch back to my blue. If I look at my total, oxide has a -2 charge. So here, my total negative charge is -2. That means that this iron has to be +2. So this has to be iron. Actually, I wrote that wrong. That should be iron. Should put the abbreviation with that. Iron 2 oxide. But this guy, I have, each oxide has a -2, but I have 3 of them. And so this has to be -6. So here I have a +6, but this, oops, I'm off screen. Let me pull this down. This guy has, so if I had to write out what I have in this compound, I have 2 irons and I have 3 oxides. So this is -2, this is -2, this is -2. And that gives me that -6. Now I have a +6 here, but that's spread out over 2 atoms. So that means this one has to be +3 and this one has to be +3. You have to spread the charge evenly out. So that tells me that if I'd written iron 6, that would be wrong. There's not even an iron 6. That tells me this has to be iron 3 oxide. All right, let's see. Let's do another sample problem. Let me come up with one off the top of my head. How about copper? Let's do Cu 3 and 2. Okay, pause the video and come back and we'll do this as a sample problem. All right, so if I have Cu and N, remember this is a monoatomic, so this is nitride. Nitride has a -3 charge, and I have 2 of them. So I have a total negative charge of -6. So that means my total positives over the coppers have to be +6. Well, I've got 3 of them. And I have to spread this charge evenly out over all three. So if I take 6 divided by 3, that's going to give me +2 here, +2 here, +2 here. So this compound has to be copper 2 nitride. So we had a couple of different things here. We have polyatomic anions. We have a monoatomic. We're getting review on that. But the main takeaway here is how do you determine which type 2 cation you have? You have to do this little kind of calculation here, and you have to look at your total negative charge. And then you spread that opposite and equal and opposite positive charge over your cations. All right, you'll get some more practice homework, and we'll go over how to write these formulas in part 2.